So basically, we cover this program structure. The simple one, actually, we skip this one, right? We skip this one. And then I talk about the variables location. And the number system, actually, I do not spend much time, but actually it is quite complicated. And then the one show here for the character, show character, long, it's different data type actually. For different compiler, it can be different. And also, there are 3 different version. You have the -std C99, you have -std C11, you have -std C14, C17, okay? But the version I download probably don't have the C17 because I probably download 2-3 years ago. But long, sign, unsigned, if you want to write a number, you need to put something like this, okay? If you want to have 65 for long format, you need to put something like this. And actually, I forget that when you do printf or scanf, you actually need to do %sign LLD, something like that. Actually, I forget that. Yeah, sorry for that. This one, actually, I missed that one. But that is quite important. Okay, but to adjust this, actually, when we do compilation for this long stuff, if we actually initiate a new program, okay, console and then select C project, okay, and then let me actually go up. This one is chapter 2. So C course, C double plus course, C dev. Okay, here I create chapter 2 here. Okay. And here I create another, this one called data type. Okay, in data type, I put this project 1 over there. So basically, this is C program. And here I want to show what is different data type. Okay, so basically you have a long, and then you say you want to have a 65, you need to put 2L after it, and then you have the print F, right, something like that. And then you actually do the format. So you have print out this one %LLD, right, and then A. So that is one is this one specify the numbers format is 65 LL format, and then print out with that format, and you actually compile. So that's save as a min. And you pass, and then you can run, right? And if you want to set the flag, you go to this project option and select the parameter. Since this is a C compiler parameter, so you can specify std equals C99, okay? You will select the C99 version and you can compile and run, okay? And if you want to have C actually parameter as C11, this one is C 2011 version. You just you want to compile with C 2011, you just write -std equals C11. Okay, so if you are using the C double plus compiler, you just specify C double plus equals C plus plus 11. You'll get the different version of the compiler. Okay, I'm sorry for this. Okay, so that is where you need to set your compiler flag. Okay, these are the compiler flag you need to set. And let me see, this one. That's one of the compiler flag usually people will set. And then there are some other one are also very important for the compiler flag. Another one is the -WO. This W means warning. So when you turn on this, it will turn on all of the possible warning for you, but it actually your program will not be as easy to pass as well as normal. So here I can say HWALL, so something like that. So you can see here, if I pick up something from Google, and you can see here, you can type GCC WAL means, okay, there's a GNU compiler, GCC, let me see, you should have the flag, I'm sorry. Option index, here has different option index. And if you see here, there are several option index. -F, different thing, -W for warning. So it's a warning option. And then when you assign -W all, ALL, that means all warnings. So you continue through, right? It will give you warning if you have some warning. It will actually give you the warning if you get some warning. Okay, that's the one. If you do it inside this environment, you just go to this project option and choose parameter. And if you don't know about the option, this one is an option list for C. There are quite many of different options that you can choose, you know, but this is too many. So actually for compiler option, it actually is very professional job. Okay, some people just do this for life. So let me pass this for you. Okay, so Eric, are you okay with this?
Yeah.
Okay, so this is something you need to learn, okay? So here for C, C++, all have different flag. It's not like Java, we usually just put nothing there, you know, we actually don't know about what it is. But in C, C++, there are tons of flag need to be turned on, okay? And then if this one is, if you go in this environment, it's something like that. And if you go to your Windows, you go to your project, so since you go to chapter 2 in the project you have in the same window directory, you need to bring up this, right? And over here do CD, and then left mouse click, and then right mouse click, copy, go back to my window, just click right mouse click, and then hit return, and then say dir here, and I say gcc main.c, right? Before I did that, if I want to turn on the flag, I say -std equals C11. That flag will be matching the one that you see from the project option over here. Okay, that one will match that one. That one actually will match that over there. And then here I say main.c-o test. Okay, so here is the source program. The test is the executable program. And when you do dir, you know, original I have I have a project 1.exe, but now I changed the name to test.exe. So right here I say test. You print out 65. So here is one flag I can turn on. At the same time, I can also turn on this warning all, and then test attd equals C11 main.c-o test. Okay, but this one it passed without warning. Some of the things that actually will cause the problem when we do compilation is, for example, here if I have the one like for int I equals 0, I less than 10, I plus plus, And then here I say print F. And then I am fine. Okay, something like this. This one will cause problem. Now I actually turn off the flag. Turn off this flag, okay? And I just keep the the warning, all warning. See right here, it won't pass, okay? If I turn down the flag, it won't pass. So I have to actually turn on this one, probably C99 will pass. So if I turn on this std equals C99, so the one without any flag, that one would be the 89 version. I'm sorry, let me compare it. Oh, it still don't pass. So actually, I actually come to here. 99 still don't pass. Let me change it to C11, and then C11. Oh, actually, probably it's not a problem. Probably I need.
No, need a for loop. Your for loop. Integer I, it needs to be outside.
Yeah, I know, but suppose, no, I forget the semicolon. I use a new flag, it should be fine, right? And actually here, right, it still have a warning because I turned on the -WO. So the warning still show up, but it's compiled pass. But here, if I say this one, I just delete this warning O. If I delete that from the option, it goes through and it has no warning because some warning just don't show up. You see the difference? You see the difference? The one I don't turn it. So right now, if I turn even this one off, it will be using the C double plus C GNU C 89 version, and it actually pass. Oh, maybe that one is okay. Some of them will not pass. Okay, but if I do outside, let me see. If I do outside, and then nothing. Yeah, this one won't pass, right? This one the int won't pass. This will use the default one, so it will be 89 version. So you have a C99, C GNU 99, C11, C GNU 11. So the one I installed for that C double plus is only up to C11. But if you need some newer version for the GNU C, you say GCC C17 for Windows. You can check for that, but you need to actually search for that. There are some downloadable version you can install. But for now, I actually don't need a C17, so it's fine. There are some newer version, but this one actually, this one I think is more convenient. You just turn on C11 all the time. You'll be or C99, unless like your teacher require that you don't turn on the flag. Otherwise, it makes no sense that you actually run in those old flag and debug some meaningless. Since the C already moved on to newer version, so there is no reason that you don't turn on the dash standard those flags, right? And actually something to know. Okay, so those actually are something, and also. In here, if you want to do that, include the bool std bool.h and include std int.h. Okay, these two things, right? So this one actually allow you to declare volume variable x. Let me see, call it b. Okay, equals here, right? And then here, something like this. Okay, so this is some Boolean variable, and the integers, the so-called unsigned integer 64. Let me say, see, 32 tx equals 0x 0, 0, 0, something like that. This will pass with the C11, so you will have the Boolean variable and something like that. But actually, if you say if 1 in C language, 1 non-zero means let me see. Wait. LD return something wrong here. Oh, he's print. I should be have print F. Sorry. You know, this tend to have some error. Okay, this is fine. Okay, it passed, right? So here, if I say print 3, if 3, okay, it's still print out good morning, okay? And if I say if 0, there is no good morning, okay? But if I say it's like -1, -1 still pass. So as long as it's non-zero, it will pass. Why -1 actually will be true? Why -1 actually be true? Because -1 actually is an integer, right? It's an integer type, but when you do a logic operation, -1 actually is in 2's complement format, and 2's complement format it actually is 2 to the power 32 minus 1. It represented as this. So actually -1 in reality it is not real negative number. In the computer actually represented by 1111, 1111, totally A of them, because A by 4 equals 32 bit. So it's actually something like it. Continue for 32 bit. Okay, right here I try to explain more bit level thing for you, because you need to study C and assembly in your 51 course. Okay, so bit level operation, you need to be aware of what is going on. Even though it's -1, but it actually is in 2's complement format. And 2's complement format, it means that 2 to the power 32 minus 1. 2's complement, if you have an x, the 2's complement for x, for minus x, is represented as 2 to the power 32 minus x. That's the number of bit representation. Is that okay so far?
Yeah.
So the -1 actually in real number checking for binary, it actually is 1111, totally 32 bit of 1. And here, as long as it doesn't put 0 in there, only 0 will be false, okay? Only 0 will be false. And on the contrary, this 0 return value, only 0 is no error. Only this guy is so any non-zero means some error, okay? For this 0 that it return. In fact, it actually is also when the system program you write some bombshell script in Unix or Linux, when it tests the return value for a program from your own program, actually you'll be something like that. So once you go to 53 course, that you write a bombshell script, or you write a C shell script. These are similar, not much. There are some difference, but it's similar. It actually also, C shell also look very like C, but it's a script language. When you do Linux, right? You can do some script program, and you will run just like if L something like that, and then And then if you have the if something like this main program, so the main program and put some parameter here in, right? You will run this C program, and then if the return value is -1, it would go to the else part, for in the script. So that's why you need to have the return value, because when you handle it in system level, it will have such a thing that you need to handle. So actually, if you go to the this guy, go to Google and you say like shell script, something like this. Getting the exit code of shell script in the C program, okay? So something like this. This one is actually a shell program, okay? So let's look at the answer part. So this is a shell program, right? And then if you run a certain program, it will return some value. Okay, so the return value actually will be 1, 2, 3, 4. So this one equals 3, so it's an error code 3, okay, or error code 4. And then if your program say return 0, that actually is healthy return. There's no error. Okay, so some program, so this is a script. And your C program is like this function there. Okay, your program is like this function there. Your program is like a function over there being called. So that's why in every C program, in every Java program here, you have something like this. It's like a parameter you take in, and then you will return something to the system. Okay, that's the what we have. Postpone. Okay, let me see. That's the C progress interface. Okay, so these are actually you can get the unsigned integer or even signed integer with specified format. Okay, the reason why this may be sometimes better is because in the old C double plus, as you know, whether int, how many bit is int, we don't know. Long, sometimes it's the same size as long integer, and sometimes long, how many bit, we don't know. It actually is not well defined. So a better way to do more standardized programming is actually like this. You have unsigned, you say that put a U in front of it. If it is signed, you put the integer A for U. Okay, 64-bit, you just put 64-bit. Okay, but if you actually look at the std.int.h, you will see that actually this 64-bit will be converted to a certain format for you. So let's look at the std.int.h file. Okay, if you go to there, it actually is printing for you what it is. Okay, if you type like the source code for std in, right? This one actually is the program, real program for std.int. Okay, as you can see right here, okay, it has the type define something, right? So if you look at here, you will type define long integer is the faster 16-bit, okay, something like that. So fast 16-bit actually define these three type all defined as long integer, okay, something like that. So you can look at the different format of the integer, and here also has the int a minimum, int 16 minimum for the constants you can use. Okay, it's defined as a macro. So when you include this std.int, you have all of these included. Let me check if the data type is there. That's what I really interested in. Actually, what I interested is the basic this int type. Okay, So here it has different conversion of different type. Okay, these are the type. So it actually also include the bits standard. So there are some file maybe defined in here. Okay, it will explain. If you look at it, it will explain what it is, and it said that it's actually C99 standard. Okay, C99 standard. So you can browse through the internet, and then you will know the definition for this different thing. But the good things are for user. Actually, you don't need to remember that. You just remember is integer A. That's the integer, and the value range is like this. Okay, and if you want to see the minima and maxima, just like the previous page here, if you want to use the minima for the data format, you just put in A min, in 16 min, or maxima max, or unsigned max min. Okay, and underline T means type. Okay, so this is fine. And two's complement, I explained a little bit here. Okay, so if you have integer x and its negative number is represented as 2 to the power n, this one is the number of bit minus x. Okay, and 2 to the power 8 minus 1 minus x, and then plus 1 is equivalent to this one. And the previous part, this part, we call it 1's complement, because 2 to the power 8 minus 1 actually is 1, 1, 1, 1, 1, 1, 1, 1. And then if you have 1, you minus it. If the x equals 1, you will get 1, 1, 1, 1, 1, 1, 1, 0. So that actually is the big flip. You just flip 0 to 1, 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 1 to 0. You will get its 1's complement. Once you get your 1's complement, you plus 1, you'll get your 2's complement. Okay, that's the fastest way to find out what's the negative number being represented in your number system. Okay, that part is fine. The 14 point, I explained it before. This operator, actually, we know that I explained it. Increment, decrement, I think you know the augmented result for the becomes increased by, minus by, multiplied by, division by, 10 multiplied by is okay. Now here as the bit level n, or bit level inclusive OR. Those part I don't talk about it here. Now let's look at, here we have the logical and relational operator, and I explained it. But the only thing is that you need to know that you can use integer here to represent Boolean value. Other than that, I think you are fine. Okay. So now the next topic I'm going to talk about is this bitwise operations. Okay, and shifting. Okay, those are more interesting. So here has a whole section of the bitwise operation and casting. Okay, these are the topic the main focus for today. Okay, so now let's get started for this part. Today we are in the bit level operation. Okay, and it's quite important for this bit level operation. Okay, so before we go into the deeply in the bit level operation, let's look at the truth table first. Okay, let's look at the truth table first. I know truth table probably not that difficult, but if you have a variable, b variable, right, and the output for a variable, b variable, you can draw a truth table like this: 0, 1, 0, 1. You get 1, 0, 0, 0. This guy is called a bar and the b bar. Okay, this guy is called a bar. This is one way to do a truth table. The other way to do truth table is you use the list down method. Okay, you use the list down method. You use a list down method. You have A and B, right? 0, 0, 0, 1, 1, 0, 1, 1. Use the numerical way, and then this one A bar, B bar. Okay, you get 1, 0, 0, 0. Okay, that's another way to do it. Okay. But both has advantage or disadvantage, okay? Because this using this column way, you can put more variable there and then continue to do calculation. But this one you can have only one way to do it. but this one actually, the left hand side one also has its own advantage. Say if we erase this, okay, if we erase this and then we have this, and then I put 1110, right? This one actually is what? Is actually is A or B, right? But logically, how can we actually get the A or B fast? You can have this guy and this guy, right? It actually is, this guy is what? This guy is actually A. And this guy is what? This second block is actually B. So it's actually A or B. Okay. And for in a larger function, you put the whole block. That's one block. This block plus the other block, you get your larger function. Okay. But in this column chart, if we erase it, and I put the number in, it actually is 0, 1, 1, 1, right? And right here it's harder to group. It's harder to group because if you group this one, it's not A or B. It's not easy to group. So a modified way to draw a truth table is like these two. Let's swap these two. So here I put 1, 1 instead of 0, 1, and here I put 1, 1. So these two, when I group these two, when I group this center two, it represents for B. When I group the lower two, it represents for A. So actually, you make such a modification, you will be able to see this one actually is A or B. Okay. Is that okay, Eric? Hello?
Yes.
Okay, this new way, is that okay?
Yeah.
So you swap the one. Okay, this one is actually easier. Let's look at something bigger, okay? Let's look at something bigger for the truth table. So, for example, if we had A, B, and C, okay? A, B, and C I draw it down as this, right? But so here I have 0, 1, 0, 1, 1, 1, 1, 1, 0, I'm sorry. Here I have a C, right? C can have 0 and 1, right? Okay, so I draw something like this, right? And then let's see, here we have 1, 1, 1, 1, like this, okay? I don't know what function it is right here, but let's analyze this one, okay? So I have this one here, right? Regardless of C or C bar, my A and B is true. So this one actually is A and B, right? And then plus. Second one, I have this one. What is that? It actually is this one only happened on C bar, but not on C. So it's a C bar and B, right? So in a three variable environment, 2 bus means 2 variable. Okay, only 1 point means 3 variable term, and then 4 bucks means 1 variable term. So right here, if I circle this one, it actually is C bar and A. So this one is C bar A or B plus A B. Okay. So this one is C bar A or B or B, and this A and B, and this actually is a function we can derive from here. Can we further simplify it or no? Probably not. Okay, so that's the function I will end up with. The term I will end up with using this Boolean variable, right? So let me actually erase this. Let me erase the red one. Okay, these are the things that you will learn 51. In your 51 course, it is covering something like this. Okay, the logic operation, and you need to calculate it. And then the next one, if you have here, let's assume that it's all happening on here, right? So C doesn't matter, and then A doesn't matter. So right here, actually this one means B. Okay, this one actually means B. Okay, and let me erase it. This one actually means B. Is that okay for this B? Hi, Ari, are you okay with B? Hello?
Yeah.
So let me throw one more. How about this one? C doesn't care, right? And A doesn't care, but B is what? C doesn't care, A doesn't care, and B is what? I'm sorry. B is what? B is 0, right?
Mm-hmm.
So this one actually is B bar. Is that okay? And then that's how this works. It actually gets to something like this. These two belong to a block. Is that okay?
Mm-hmm.
So get used to this. It will help you to do the truth table better. And these are the something you need to exercise. When you go to that design in logic design. Okay, logic design is important when you do B-level things. Okay, so right here probably I'll stop here, and because we have something else to do. Okay, but later if we have opportunity, I'll continue to teach you this. Okay. Now I'm going to do something else. Yesterday I talked about this for the bit level operation. Now we have AND and OR, right? We have AND operator, this one, and OR operator, this one, and cap, right? For bit level. So as I said, if I have a data, this one, right? This is my data, right? If I put 1111 and 0000, and these two numbers actually let me do OR, right? So the data in the red will pass down when it is 0. So this one actually is 0. So this part for 0 is passive. For the this operator is this OR, okay? If it is 1, it actually means like second, so everything become 1. So the result of this bit operation would be like this. Okay, that's the OR operator. We use the OR operator. And what's the OR operator do? OR operator is useful when you assemble the data. When you try to assemble the data. So let's look at the OR operator. As I said, if I have a data here 1110, right, and the rest of it 000, okay, and another data I have here 1111, and other section are 0, right? And then here I have 0000, another section are all zeros. Another number here I have 1101, and the others and I actually, if these four numbers all together, you'll get 1110, 1111, 0000, 1101. So actually, you can pack the four numbers together to an integer. Is that okay?
Yeah.
Is that okay? Okay, that's so usually the OR operator is used to pack something or put something together into a bit, right? And then as I said, the AND operator I use for extraction. So this OR is more like a put function, more like a put function, or more like a put function, and then AND more like extract function. You said that you need to be careful about 0 or 1. So here, if I want to extract this one, right? I just want this data out. I just put 1111 here because I do end. Only this one will survive. The rest of them I put 0, 0, 0, 0. So it will be killed out. All of these are 0. I only have the 1110 data. So this one end is used to extract data out. And then you do proper shifting, you'll get the data, the desired data you want to have. Is that okay?
Yeah.
So that's the basic function when you do the operator, the bit level operator, you need to take care of. So now let's officially look at this bitwise operator, number 1. And I know probably very few teachers when they teach C++ will cover this. So let's look at the bitwise operator. Bitwise operator basically has this one 0, 1, and then inclusive OR, and then this one is bitwise complement, so that's negation. Okay, let's look at these 4 operator. What's the function? Okay, so if I explained the AND and OR already, right? The next one is bitwise inclusive OR. Bitwise inclusive OR means what? If I have a number called 1111, 0, 0, 0, 0, 111, 0, 0, 111, right? And I actually bitwise exclusive OR with 0, O0 here, and O1 here. If I have this bitwise inclusive OR operation, what would be the result? Eric, do you know what is the result here?
What if you use
Bitwise
exclusive OR?
Yeah, so only they cannot be the same, right?
Yeah.
So here actually you get what? You get this one 0, 0, 0, 0, 0, 0, 0, 0, right? And this one actually 0, 0, 0, 1. This one is 1, 1, 1, 1. Okay? So bitwise inclusive, let me explain it. If you look at the 0 part, 0 part seems it's all 0, so actually if you are 1, you will be 1. If you are 0, you will be 0. So 0 part is passive. And 1 part actually means toggle. Is that okay? So you take a note, okay? You take a note. The OR operator 0 means passive, right? Let me actually put into the whiteboard again, okay? So we have 3 operator, right? We have 3 operator. So for OR operator, if it is 0, it means actually means passive, right? If it is 1, the mask is 1, it actually means set, right? For AND, 0 means what? Clear. And 1 means passive, right? And then for cap, the inclusive OR, 0 means passive. Passive means the data will flow through. And this one means toggle, right? And negation is unitary, so you actually just toggle. It is only like negation of A, you actually just toggle the number. Is that okay? These are the 4 operators, and these are very important. You need to remember these 4. So OR, you see that this OR is 1, so it's setting on 1, okay? And AND, you know, it's like when you have 0, you print something, right? And then cap is that when there's a 1, you toggle it. And negation to toggle. You remember these 4 basic concepts. It won't be too hard to know about what is a B-level operation. Okay, and then shift left, shift right. Okay, that's simple. Just how many bits you have. So here So here usually and you will have A and the mask. Okay, and then the mask, as I mentioned, one part is actually pass. Like the 0 part, no matter which bit it is, it actually is clear, right? That's the AND operator. And then A or mask. The mask, this is for the mask. The mask part, if it is 0, it actually means passing. If it is 1, it actually set. Okay, so you need to have a concept of mask. What is mask? Mask is something to filter out something for you. Okay, and then this bitwise inclusive OR is passing, or 0 means passing, 1 means toggle. So if you had a cap with mask, it will behave like this. 0 is passing for the mask bit. Okay, and then shift. A2 means shift left for 2 bit. A right shift 2 bit. Okay, and then there's a negation. It's bit level negation. So these are 6 operators for your bit level operation. So here, example for bitwise operation, you have the X and Y, and then X and the mask bit Y and this. Okay, so it's OR and cap. Okay, it's easy, but it's more important to understand what is the function there. So here we have the bitwise AND. So when you have the AND, this one, right? 0 will be clear, so 0 will clear. Whatever you see a 0, just put 0 there, right? And if you see 1, just let the data flow through. So let's look at this one. Are you okay, Eric?
Yeah.
So this 0 is just actually clear. So these 3 are cleared, right? This one also clear, right? So pass through, you have 0, 1. This 1 is also clear. So only 0, 1, and 0 pass through. Is that okay?
Yeah.
That would be easier to understand what it is, okay? And you can run the program, but actually, I don't want to do that, okay? So here for this OR, and OR, you need to follow my rule to understand it. So basically, you have a 1. When you have a 1, it pass through. So this is 0 and 1 pass through. This 0 pass through. So it's actually this pass through there, right? I'm sorry for the part. I'm sorry. I need to clear it. No, not like this. For 0 part, it pass through. So this 3-bit 0 pass through to here. This pass through, right? 0 part actually this 0 part pass through. So this is 1 and 0 pass through. The rest of a 1 you have a set. So we set 3-bit 1 1 1 over there. Okay, that's a setting. So that will give you better idea of what it is. And then here we have inclusive OR will be the toggle bit. Okay, toggle bit 0 it pass through, and 1 it toggle the bit. Okay, and then complement you actually just negation on each bit. Okay, so now let's look at the BYC BY.C. Let's look at BY.C. Okay, chapter 2. Bitwise.C. Okay. So here we have this Bitwise.C, right? And I have M equals 40, B equals 80, and I have different operator, right? Operator operation is like having the mask. So 40 is actually the mask, right? And 80 is actually the value want to work with the mask. Okay. I'm sorry, N is actually mask, and that M is the value. So actually, this one is probably hard to see what it is right here. Okay, so you can convert to a binary format. I will explain the whole thing better. Okay, and then printf binary is like So when you do printf in binary, actually you need to do bitwise conversion. It's a little bit complicated. Okay, so usually I will use a hexadecimal to print. Use percentage X to print now. Okay, that would be better. But I don't want to walk into the part. So let's look at this second part for bitwise operator. Okay, so now it's shift. Shift have two kind of shift. Okay, it's there's a logic shift, left shift, right shift. Okay, and then there is a logic right shift. Okay, three different shift. Okay, left shift and right shift, two angle one is the same. There is another additional called right logic right shift. Okay, and the logic right shift, three different shift. Okay, so the logic right shift and the arithmetic right shift are different. Okay, let's look at the left shift. So my initial value is 212. Okay, is binary, and then I left shift by one. So actually, if I left shift by one, actually I'll add a zero on the at the end, right? I'll become this. Okay, if I shift this 0 bit, actually is the same. If I shift 4 bit, you would actually add 40 at the end. Is that okay for here?
Yeah.
Left shift is easier. Right shift is more difficult. Right shift, if it's arithmetic shift, you use the 2 shift bit. You will have the if it's positive, you will actually add in the zeros. If it is a negative, if it is a negative number, you actually will get sign extension. Okay.
Mm-hmm.
So right shift orbit toward the right a certain specific amount. Okay, it actually will shift. So here, when I shift, it actually will just divide. So actually, you will put 0 in front of it. 7 bit, you will only have 1, so it actually shift over, right? So this actually is what? It's just shift the bit and insert 0 in, right?
Mm-hmm.
And then if I have, so here, if I have this one actually represent the operation. But there's another one called logic right shift. Okay, logic right shift actually, if you shift like 1 bit, it will be like this. There's no problem. But if so, logic right shift is 3 angle greater than. Okay, so actually when the lost bit, let me see. This one, let me see. Okay, that's it for this. So this one actually let me see. If the number is an integer, right? If the number is an integer, the arithmetic shift will exactly like right shift, except that it will, instead of padding 0, it pad with most significant bit. Okay, this is because the most significant bit has a sign bit or the bit that differentiate between positive and the negative numbers. So that's called sign extension when you do arithmetic shift. So arithmetic shift is what? Arithmetic shift is 2 right angles. So the one actually I use. So if you are a unsigned integer, right? If you are unsigned integer and you shift 2 bit, it's fine. Either positive or negative, you will pad with 0. Okay, you will pad with 0. But if you are integer, right, and you are negative, say you are 1, that one is actually 255, right? But it actually represents minus 128, right? In that case, if you shift right using this 2 angle shift, you will pair with 1 in front of it. That's called sign extension. Is that okay? And logic shift actually will pad 0. For logic shift, it will pad 0. So remember the NAND logic shift. If you need to just shift the bits, and then pad with 0 in front of it, you actually do this. If you want to do like a division by 2, that's called arithmetic shift. That one actually you need to use a 2-angle shift, especially for negative numbers. Is that okay? So for positive number, they have no difference. But negative number is two shift or three two shift or three shift have difference. So let's look at the shift .c. Let's look at the shift .c. So in chapter 2, I have the shift .c. You know, every chapter in my book, I have this simple program. So here, I have 64, right? It's unsigned integer, and I shift 1 bit, 2 bit, 3 bit, right? So actually, if I shift 1 bit to the right, it becomes 32. So then 32, 16, and then 8. Okay, so that's wrong. Okay, that's the shift number 1. So this is a simple shift to the right, simple shift. Now let's look at shift number 2. Shift number 2, I have 2 unsigned value. One is 60, one is 13, right? And the shift number 2, actually, I perform the AND operation, right? So basically, I have this A and B. So what's the result for A and B? Right here, if you do AND. Eric, can you look at this?
Yes.
What was the result for this A and B? So for A and B, if it is 1, it will go through, right? So it's 0, 0, 1, 1, 1, 1, 0, 0. Here we have a 1 over here, right? So 1 will pass through, right? And 0 part will be clear. So that one actually you get 12. Is that okay?
Yeah.
And then the next one, you have the OR. So you have 0, 0, 1, 1, 1, 1, 0, 0, and then 0, 0, 1, 1, 0, 0, 0, 0, 1, 1, 0, 1, right? So for the 0 part, it will go through. So 0 part, it will go through. And 1 part will be 13, right? It ends up with 61. Is that okay?
Yeah.
And then for this one's, the next one, toggle one. So I have 0, 1, 1, 1, 1, 0, 0. So sometimes I just put the 1 on, okay? Put the 1 on. So 0, it will pass. So 0, it will pass. And this one toggle original, so 0, 0, and 1. Okay, so that one is for toggle, is 49. Okay. And then this one, negation actually is for negation of A is actually 1, 1, 0, 0, 0, 0, 1, 1. That one is okay. And then A shift that would be 1, 1, 1, 1, 0, 0. Okay, but it's an unsigned integer. It's actually 32-bit. So actually it still be a positive number. So it's a 240. Okay. And then left shift to the right, you actually end up with this 1, 1, 1, 1. Okay. So let's run it. Okay, that's the result we got. Okay. That's the result we got. How comes the C number 4? Oh, that's a negation, so it's a minus 10. Okay, that's fine. Because the rest of the bit are 0, you actually negate to 1. Okay, so that becomes a negative number. That's fine. Okay. So the next one is casting. Casting, we know it well so far, right? So integer division, you need to cast to the proper data format in order to do casting to non-integer division, right? Cast it to floor or something. And if it is not the right format you want to have, she will do promotion instead of just simple. She will do promotion to the closest format instead of just convert it to integer. It will use the promotion rule. Okay. So type conversion, I think is very easy. So there are two types of conversion. One is the implicit conversion. The other one, that's automatic type conversion. The other one is implicit. Implicit, you would need to do it by yourself. Okay. And type conversion, you have these different hierarchies. So basically from character short to long integer and long and then double. Okay, something like that. That's the so character and short operand are converted to integer. Low data type are converted to higher data type as a result higher data type. Okay. But unlike C, unlike Java, C doesn't allow the automatic casting to string. So we need to use the toString method. Is that okay? We need to write your own toString method to convert it to string. Okay. And to convert the C data to string, there is no C out, those kind of thing, but there is a string print. Okay. So the way you actually the way you operate the toString in C, actually there is some function called string print. String printf. Okay, in C language there is a string printf. Okay. So what happened is like I have a capture buffer, right? So this capture buffer actually is for the so-called string storage, right? So right here you have a formatted string format, right? Just like normally you do printf, right? And this string number will be replaced to the D over there, right? And eventually after it print, you print to the buffer instead of printing to the console. So this buffer actually is the toString result. It's just like equals that whole thing does something to string. Well, toString to this buffer. Is that okay? So there is no toString function. They use the sprintf. And sprintf will print the result to a string called character buffer. Is that okay? So C has no toString. You need to use this one. But let's look at the version that I have for C++. Let us look at the version I have in C++ for toString function. You probably see it many times, but here let me explain it. The toString function I have. Let me choose a simple one. Maybe this array is better. Okay. Let me see if there is let me see. No. Yeah, don't download it. Okay. So let me see the toString function. Okay, toString function is right here, right? So here, be careful. It's called so in our C language we had a printf, right? The printf you had a formatted print inside here, and then the parameter to replace it, right? And you print to console, right? So when you do to sprint, you put your target character array over here, and then steal the format here, and then data update. Eventually, the data will replace the number there, and then will print to the string over there, right? That's the toString function in C you can do. And right here is similar to the C level, but you need to include normal output you print to the console is the IO string. But for string output, you do the S string. Okay, for the string output, you use the S string. So similarly, you declare something called S string, S string type. So the string is right here. So here in the S string buffer, so here you have a template, right? So template T. So here this T can replace any integer or double. That part is fine, right? And then you have a O string. That one is actually from the SS string class, right? So you declare a certain string like this, right? And then you actually push into or insert the number just like a C out, and then you put a certain integer like I over there. It will be converted to a formatted string format to a C out if you put into a console. But this one you will just put into a string or a string. So a string actually will be collected into a string. And then at the end, you use the .string method to convert that string object to a string format and return it. So the program itself is not that hard, except that the cout is just like printf. You print to the console. This stm, so this one stm, you actually can call it sout, right? That's okay. String output, that's okay. And then you use the sout.str, that's also okay. So this str just get a string format out, and it will convert to string and help you to convert the data. Is that okay? So this one is not really hard to understand. So every time it's just like STM, just like CL, you can insert everything into there. And at the end, you just do stm.str to convert the string out to the desired output you want to have. Okay, so that function is not too hard. The other part is may bother you is this one T actually is can replace by this angle bracket T. Okay, that's the only thing. But in fact, when you call it, you just need to do toString. If an integer I will be there, the type you will automatically detect as an integer. You will replace it right away. You don't need to put into the angle bracket. Okay, but this one is called a generic function, help to process different type. But this one, because it's actually a type name, so it can only handle what? It can only handle the primitive data type. It cannot handle object. Okay, so once it is object level, you need to use these toString to help it. Okay, that's the type casting. Okay, toString, and this one explicit casting will be similar to whatever you can you have in. It will be similar to whatever you have in Java. Okay, so let's look at this casting function. So casting function, you have 65 unsigned character. You can cast it to character and print now, and then increase the number, something like that. And you can do implicit casting if you want to convert it to the decimal value instead of print out as character. So this way, the same A you can print out with as character like %C, or you can print out as a integer if you print out as %D. Okay. So this part is also simple. I think this chapter, the rest of the chapter is actually simple. More difficult part is the binary part, but this one is simple. Okay, so that's a simple program. And then the last one is conditional expression. Conditional expression is similar to Java. Put the binary condition there, and the block 1, block 2 as the return value for the conditional statement. This one is okay, right? This one is okay, right? Hello, Eric.
Yes.
The only difference is that the condition can accept integer now. You know what I'm saying? It's different from Java. The only difference it has is like The condition can be an integer. It can be as long as non-zero value. You can do that. Okay. So
Okay.
that program I don't actually look at it. Now the next one actually I explained it previously, but here is the reference and dereference. For C language, this one is called this declare a pointer P as a body, and you assign the X address to it, and then the body is called dereference. Put in the start code. So the body assigned with 20. Okay, that's the body assigned with, not the pointer itself. Okay, and X sign is called expression. Okay, it's actually called reference. This one's called reference or called address. Okay. So here one thing we need to know about, actually not related to C, but related to C double plus, is the use of the reference variable at sign. That one is more difficult. So right here, if you have a function, right? P function don't have this, but if you have a function in C double plus, you have integer f, right? And then you have an integer star p, and then integer a, and then integer at b, right? Okay, these two are easy to understand, right? Because the a in C double plus, I'm talking about C double plus, the a actually can only be input. B can be input and output. You can modify the value, right? So when you have a B, S sign B, it actually called reference. Okay, A actually is like A have a variable, so you can only put 3 in there. If you in your function you say A equals 3, you put 3 in there. Okay, B is a reference. You put the H as B, and then when you call, you actually call F of say P, A, and then B, right? This B when you call, it actually has the S sign. So actually, if B equals 5, B will be changed. It's not the local variable. It actually is the outside variable. B will be changed. Okay, that's here. Okay, and then P actually is actually a pointer. So when you want to change the variable, the P point to. So P actually is like here. The H is pointed to here. So body P equals 3. It actually is changed the one it pointing to. Okay. But now the more important question is, if I have this one, sometimes I have this integer si function f of integer a, and then a, right? And then integer si b, right? And then b equals a, and then actually return b. Well, what does this really mean? What does this si really mean?
I don't know.
Right? You see that the string in your homework, you see this happen, right? This actually return the, okay, if you don't have this, right? If you don't have this, and you don't have this, right? This put 3 in there, you return 3. That integer 3 will be returned, right?
Yeah.
Okay, but if you have that one, right? So right here, I don't put this B, okay? So if you have that one and you have a over here, and I return the address of A, and here I put this, that actually will return a, say F of F, you will return a value. That one is actually a left-hand side value. So this one actually can be assigned 3. That means this A will be updated by 3. So that one is something that can be updated. Who used this function? Who used this feature? In your homework, you have someone actually use this feature. If this one actually return the left-hand side value, the left-hand side value is a reference, not a value. You actually have some function in the homework actually use this. Let's look at that one. Okay, that's interesting. That's the kind of thing I want to emphasize more. Let me see. Your budget, your assignment 3 actually already has a. I remember you have some string. Let me see. Not in here in the .h file. Okay, in .h file. Here you had this, right? Remember that? This one has a character and S sign, right? Yeah, this one, right? Operator bracket, right? And then let's look at the string implementation. There should be a bracket, right? There should be a bracket and that will return. Let me see the bracket one, okay? The operator bracket. It should override this in order to work, make it work, right? Where is the operator bracket? Where is the operator? There's a character operator bracket. There should be this one, okay? Let me see. Operator equals reverse index of operator equals greater equals less than operator plus equal. Okay. How come there's no bracket? Let me see. Let me search for it. Okay. That's fine. Wait, this one don't have that. Oh, this one probably is the assignment 3. You don't have that. Let's look at the assignment 4. Okay. I remember that now. Actually, the first one, actually, the teacher doesn't require it. The first one, the teacher doesn't require it. So this one is assignment 4 is operator. Oh, here. Here he says one, this one, and this one, right? And this one, both of them override this one. This one return nothing. This one return this one. What actually does it mean, actually? These two are actually different things. Okay, so these two actually means what? The first one really give people a character, right? So you access this guy, and he actually it will be what? Getting the buffer index value maybe is stored. So buffer is a array, right? You go to an array and then maybe 3. So if this is 3, you go to 3, and then access the data, and the 3 may be storing, the index 3 may be storing 51, right? You will return the 51 and go back, right? This one is called right-hand side value. You get the values 51 and get out. This one's different. You put the same variable, so when you return, it actually create a template T, and this template T is character type. It actually assigns us the buffer index of 3. It actually is passing this reference to other people. So it's used when you do outside, say, buffer 3 equals 5. It is returning the left side value. So when people would like to assign 5, the update, it will be updated as 5. So this one actually, when you do this, say when you do buffer and then this bracket, right? You put 3, you have two purposes. One is this one equals y, right? So you assign the 51 to y. The other one is that buffer 3 equals 10 in your program. So this one, the second one, returning the reference, is providing the left-hand side value called reference. So people can use that to modify it. Is that okay? Do you get it or no?
Yeah.
So the difference, let me put it in a simpler language, is the one return integer is the return value, right? Because you override the operator, the one return value is returning value. So if this operator is like a string, right, and there's a string called a string, right? So if it is a later a string, if there is a string, string class a for some reason, right? So a of 3 equals character x. Then when we print x, if originally we have the a array, say let's say a array, a string is actually hello, okay? And then you try to assign the third one, actually is the L. So single character L assigned to X. You get a value of this A of 3, get an L, and then assign to X, right? And the other one, this is one situation you use like A3, right? The other situation is that my A3 I assign as the character T to there, right? So when this one happen, it will call this one. It will actually call this one. And instead of returning L, L is using the one above. Instead of returning L, it actually returns a temporary reference variable T. And that one actually is a what? Is an alias. So actually it's an alias of
Address.
Yeah. It's a reference. So A of 3 actually is available. And T is also pointing to the same variable. So A of 3 got assigned with T. That one will be assigned with the T character into there. Is that okay? So that's how you use the left-hand side value. That's how you return the left-hand side value. Okay. So left-hand side value, you have two opportunity you can use it. One is when you call integer f of integer a and put the reference. When you do a equals 3, right? And originally your integer b is 2, right? And then you say f of b, right? And that actually this b will be updated by 3 if you call this f of b function. Is that okay?
Yeah.
Okay. So the right hand, when you use the return value for the left hand side value, that is when this happens. It will return the left hand side value. And in fact, that's not the only one your teacher use. In fact, it's not the only one your teacher use. It is also used in here. It's also used in here, right? And in here, why is so? Why this one has the S sign over there? That's because I mentioned you will see out this with A and with B, right? And this may be a string. This may be a string, right? So when you go over there, you print out a string, the data being absorbed by out. So out got modified. Out got modified. And the out got modified and it will return something that can be modified. So actually this is something modified and then it can be something continuing to be modified. So both of these are left-hand side value. If it is a right-hand side value, it can only be available to be printed. It won't be something that you can update. You know what I'm saying? So here you actually like see out a. This whole thing can be further updated. So this guy will update it. This guy will update it. So that is actually a left-hand side value. something you can update is called left-hand side values. Just like A, this one equals 4. So this one is something you can update it. So when you do the operator, you need to return the reference instead of value. If you do A of 3 assigned to T, then that one actually is a values 51 assigned to T for character. So that is the right-hand side value. Is that okay? So with that S sign is the left-hand side value, some variable location that you can operate. Right-hand side value is only the value. And pointer is indirect value, indirect address. Pointer is different. When you say integer pointer, it means that P really install a value and then going to another variable A. So we have integer A equals 3. Is it really put a 3 there, and P is a pointer 5515, and the H is there. But if you declare someone called integer HSB equals A, actually it means another variable is not pointing same name for it. So B can be multiplied by 5, then this one got multiplied by 5. But if you have a P, you need to have body P equals 17. You will, at that time, you actually indirectly will multiply it as 17. So this one is different. This one declare a left-hand side value. Left-hand side value means it can be, you can use that to modify the original variable. Is that okay? But if you say integer B without that S sign equals A, that means copy the value of A to B only. You know what I'm saying? And if you say integer B means, oh, my B is the same as A. So I pass the right-hand side value of left-hand side value of A to B. That means that my A originally can do this, right? And then if I assign this the left-hand side value of A to B, that means when I do A equals 3 and B equals 3, they have the same power. Same power to modify my own A variable. So this is assignment of the right to be modified. Is that okay? That's called alias. Alias or reference. The right to allow other people to modify. That's another ID. And that ID can also be a return value for a function. And we see many times here. But this actually is possible only for C++. For C language, there's no something like that. C language, if you want to modify something, you can only use pointer. Is that okay? So relatively, pointer is a little bit more easier. So reference variable SI, which means take the edges of expression, and then the function designate is actually it's a left-hand side value designate an object that is not a big field. Okay, so it is used to modify something. And star sign means the reference. With star sign, actually you can modify the body, the one it actually pointed to. Okay, but SI actually means the address in C, and SI in C++ means the alias. Okay, so right here I have a structure called foo, and foo had two data fields, X and Y. Okay, and structure. How much you know about structure, Eric?
Not much.
Okay, so basically, structure is like array. Structure is like array. Okay, and in C array, so if I have an integer A of 3, that really means 3 integer 1, 2, 3, 3 integer. Okay, and C actually A will be a variable like this. It's not going to a heap. Okay, it's just store locally. But foo right here is similar. It said that one is the integer, the other one is the float. When you do structured foo, is that okay? So array is the same type data structure. Full is different type mixed data structure. So variable is full. EH is a variable full. You create a variable called is a full type. Is actually 2 entry. Okay, and then you do p val p val p val is a pointer pointing to the pointer. Okay, so variables x put 5, so integer put 5, and then the ages of var, so y puts 14.3, age here puts 14.3, and p var's y put 24, then p var actually is here, actually here you update with 22.4. And PAVR's the ages, the reference that go back to VAR, actually assigned 6. Okay, so that's how this structure works. And right here, we just briefly mentioned about it. There's a whole chapter to talk about it. Okay, and the next one is actually the precedence of the operator. So this part is actually we are to the end of the chapter now. So this one actually just need to take care of the parentheses and so here is a whole table. There are totally 16 different levels in C++, C language, and C++ probably is the most, the language has the most level, and Python instead has fewer. Okay, so Python has fewer and Java has fewer. And as long as which one take over which one, it's just a table here. You can come back to look at this table. Okay, that's it for this chapter. Any question for today?
No
question.
No.
Bye now.
Bye.